Hi everyone, this is Nikhilesh from CSE2 of Team G152. Our project title is IoT-Based Voice-Enabled Smart Vehicle Automation. So today I will be explaining the plan to execute our project. So coming to the introduction part, so let me explain briefly about our project. So our project is voice control vehicle management system where we use a web application to control the indicators and headlights, and also the web interface allows user to see the weather condition, locate his or her location on the map using the Mon Stack application which we have built. And also coming to the hardware part, it employs an ESP32 microcontroller for facilitating real-time interfaces with this vehicle system. So coming to the core components of our project, there are three main core components of our project. They are web application, ESP32 and Arduino IDE. Web application, it is built using OneStack, which allows user to interact with the app seamlessly. It also provides real-time information about location, weather and other details. It allows user to control indicators, headlights and also car details of his car. So next, the ESP32 is our foundational microcontroller, the main microcontroller which we use. Uh, it takes we insert the code into it by using Arduino IDE, which acts as a bridge between both our hardware part and software part, where we write the code into the ESP32 using Arduino IDE. It is a user-friendly interface. We can write extensive libraries of different languages in it. The data which is being used in our projects are mainly classified into two types, that is MongoDB collections and also voice command processing. MongoDB collections, MongoDB we use for user data when we sign up and log in from the interface of the web application. It stores data of the user, and also MongoDB we can also use for location and weather data which we collect from the APIs. And for voice command processing, we use examples for voice command processing. So in that case we use the voice data which we process it and also train it for better result. There are seven main tech stacks which we use in our project, out of which the first one is React.js. It is used to build our front-end application where we write the HTML and CSS code in it and run it. We choose React app over HTML and CSS because it in React we have components which can be reused every time we want, and we actually did it. And the second part is Node.js. Node.js we didn't use much of it, but we used its framework which is Express.js, where we wrote the APIs and the logic behind the website, and also we used examples to train the voice data of everyone of our team members to turn on the indicator and turn off the indicators, turn on the headlights and turning off the headlights, and Arduino IDE for inserting the code into ESP32. So this is the basic sign up interface which we have done using React app. We used JavaScript functions to write the constraints so that so that the user defines his or her username and password with all the constraints passing like length, uppercase, lowercase. Uh, Password must contain everything, and also if the user's details doesn't match after signing up, so it will throw an error which it will ask as we didn't found the user data. So we have to again sign up using the new Gmail ID and password, and then we have to log in again. This is how it works. The home page of our web interface basically looks like this, where we integrated the maps, the live location of our maps using React library, which is leaflet, and also weather. We integrated the live weather from the user's location. We collect the weather information from API, weather API, Open Weather API, and also we integrated climate control bar using basic CSS, and also the car details, the battery information, and also the fuel information depending on the vehicle. And also the music control system, we have integrated it using React icons, where we imported React icons uh, before writing the code, and then we used it for creating the music component. If a user is already logged in our website, and in case if he forgets his password, so we also built a interface where we can reset our password by giving his or her Gmail ID, where we sent a Google link. For that, we use the Google APIs for sending the link in directly to his or her Gmail. Once he inputs it and clicks on send reset link, after that we can reset the password and continue logging in again. This is a basic overview of how we have recorded and trained our voices in Edge Impulse. Uh, as we know, Edge Impulse is a machine learning model where we train our voices and give it to the hardware components so that we can work on our project. So this is the basic idea of how we have done it. The total data of which we have collected as of now is about 2 hours 28 minutes and 34 seconds. And around 4 to 5 people have trained the voices in it and made a contribution in developing the model. The basic workflow of our React app is basically like first it authenticates user based on his or her details, and then it gives access to the controls where he or she can control the indicators, headlamps, and also check the live location and also weather controls on it. And then we are still building a voice command interface on our home page where user can give voice commands, and also for indicators and headlamps control, and then it will track the vehicle current status. So these are the resources which we have used to integrate in our project. Edge computing from the edgeimpulse.com website, the weather API from OpenWeather API, and as I said, for React app, for maps, we used the React library, which is React Leaflet. So this is as of now. This is the progress, and we are still working on completing the project and looking forward to make it a grand success. Thank you.